Hello, my dear students. I hope that you're doing well in this coronavirus situation. I hope that you're staying safe and doing your studies. So, class 9 students, here I represent you the second part of our discussion of the chapter 6 that we were discussing the previous lecture. So, I myself is Shams Tanvir, lecturer of English medium day shift. So now I'm presenting you the second part of our lecture, that is chapter 6, concept of mole and chemical counting. So let's get started. So now we have to discuss the further topics in this chapter, that is the percentage composition of elements in the compound. So the percentage composition of elements means that the gram measurement of an element that is present in 100 gram of a compound, so we can call this the percentage composition. So percentage composition is, it's a formula. It equals to the atomic mass multiplied by the number of atoms present in the molecular formula in multiplied by 100 and divided by the molecular mass of the total compound. So we can see a mathematical problem. So the question states that we have to determine the percentage composition of hydrogen and chlorine individually in HCl compound. So the solution here, we can see that the molecular mass of hydrochloric acid is 36.5 gram and percentage composition of hydrogen is 2.74 gram multiplied and calculated by the formula of percentage composition, and the percentage composition of chlorine, we can see that it's 97.26 grams. So we can determine easily the percentage composition from the molecular mass of a compound. This is the uh, process. So next topic will be the percentage composition and empirical formula. So we have determined the percentage composition. If we determine the percentage composition, we can calculate the empirical formula of a molecular compound. So the formula which shows the ratio of the elements present in the compound is called the empirical formula. So it means that the how many atoms are present in the molecular formula with the ratio, with a ratio that is, the ratio must be an integer. The ratio must be an integer. So we can see an example that benzene has a formula of C6H6. So empirical formula will be 6 is to 6, that is 1 is to 1. So this is the ratio of benzene, and it will be the empirical formula of benzene, that is C and H. So this is the ratio. It means that from empirical formula we can obtain the ratio of a molecular formula, that is how many atoms are participating. So a mathematical problem is given here. It says that the percentage composition of an element of a compound is given here, and we have to determine the empirical formula of the compound. So first of all, the process is a bit new to the students. We have to divide the percentage composition with the individual atomic mass of the atom. So for hydrogen we have to divide the ratio percentage composition with the atomic mass of hydrogen, and for sulfur we have to divide it by the atomic mass of sulfur, and for oxygen we have to divide it by the atomic mass of oxygen. So a value will be obtained. So now in those values, I'll use a highlighter here. So here these are the values. So now here the smallest value of these amounts, we have to consider that, we have to keep that in hand. So 1.02, this value is the smallest value among these three of the values. So we have to divide again the values by the smallest values we have obtained. So here the second part is going on. So now we can see that all of the values obtained from percentage compositions are divided by the smallest value obtained. So now we can obtain a definite amount of a numerical value. So this value should be the empirical formula of the compound, that is hydrogen we have obtained 2, for sulfur we have obtained 1, and for oxygen we have obtained 4. So we have to just put the values of that empirical formulas, and we can obtain the result. So this is the answer, and by this process we can determine the empirical formula from percentage composition. So let's get to the next topic, that is molecular formula from empirical formula. Excuse me for a moment. So from molecular we can determine empirical formula from molecular formula. uh, Sorry, we can obtain the molecular formula from empirical formula. So the molecular mass, we can obtain the molecular formula by using the empirical formula and molecular mass of that compound. So to determine the molecular formula of a compound by empirical formula, the molecular mass of the compound should be given in your question. Without this molecular mass you cannot determine the molecular formula. We have to know the molecular mass of that specific compound at first, then we can determine the molecular formula by using the empirical formula and the molecular mass of that compound. So n will be the molecular mass of the compound divided by mass of empirical formula. This is the value of n, small letter n. So here is a mathematical problem, that is a compound having molecular mass of 180 has an empirical formula of CH2O. So this is the empirical formula here and the molecular mass given. So we have to determine the molecular formula. So first of all we have to let the molecular formula will be expressed like this, multiplied by a small letter n. So small letter n, it should be equals to the molecular mass of that compound, specific compound. So this is the uh, uh, equation according to the question. So in this first bracket we have to determine individually the atomic mass of carbon, hydrogen and oxygen. So the value will be obtained by this equation, in this equation. So the value of n should be obtained from this process. So the value of n, we have to put down this outside the bracket, and by multiplying we will get the molecular formula. So this is the process to determine molecular formula from empirical formula. So we have to know, of course we have to know the molecular mass and the empirical formula, so then we can determine the molecular formula of a compound. So in this section we have uh, we have learned that how to determine empirical formula, percentage composition and molecular formula. So these are the process that will have to be determined simultaneously. So next topic will be chemical reactions. So the chemical reactions, you have all have known some knowledge about chemical reactions. So in this chapter we will learn some more. So chemical reactions are the expression that what is happening in a reaction. The expression will be called as chemical reaction. that how many atoms and how many elements are participating to form a new compound. This will be called as a chemical reaction. So in this example, we are seeing that hydrogen and chlorine are reacting together to form hydrogen chloride. So that's a no-brainer. For one more than 1 millimeters, plus sign will be used and arrow sign or equal sign will be used between reactants and products. So this is the fundamental knowledge here. So when balancing chemical equations, you have to use integers, or you can also use fractions in some cases. So for example, we can see that hydrogen and chlorine are making hydrochloric acid, and we are just balancing the right side of this equation. Sometimes we have to balance both the left side and right side of the equation. That is, we are putting integer here, putting an integer here in besides hydrogen, that is 2, and we are also putting 2 in the right side. So by this process we have to balance both the left and the right side. So it will depend on how many atoms are participating in the reaction. We cannot say directly that we have to just balance the right side or we have to just balance the left side. It will depend on the number of atoms participating in the reaction, or we can use also the fraction. I have shown an example here. So we can use a fraction when odd number of atoms are participating in a reaction. That is, here only one oxygen atom is forming water molecule, but here a an oxygen molecule is participating. So if we multiply it by half, if we multiply it by half, so if we use a fraction, we can balance the whole equation. And in the last point, we can see that there is a substitution reaction going on. The details of substitution reaction you will learn it in chapter 7. So here aluminum oxide and hydrochloric acid is forming aluminum chloride and water molecule. So for balancing this equation, we can first of all we have to look at the aluminum, and the aluminum here at the left and the right. We are seeing here 2 aluminum and we are seeing here only 1 aluminum. So to balance this aluminum, we have to just put the number 2 here. So aluminum will be balanced. And let's look at the oxygen here. So oxygen here is in 3 amount and oxygen here is only 1. So for balancing oxygen, just we have to put the value 3. So here oxygen both will be balanced at the both side. And let's look at the next product, that is hydrochloric acid reactant, sorry, not product. So here we can see that hydrogen and chlorine, they have to be balanced too. So we are seeing that here only 1 hydrogen and here only 2 hydrogen, but already we have put 3 here, so there is 6 hydrogen, and there should be also 6 hydrogen at the left side and at the both right side. But here we are seeing that chlorine here is 3 and we have already put here 2, so there is also 6 chlorine atoms here. So just we have to put the value 6 at beside hydrochloric acid. So here both the left side and the right side will be balanced here. So this is the examples of balancing chemical equations. Now we are coming at the next point, that is stoichiometric calculations. Stoichiometric calculations will be the branch of chemistry which defines the amount of product and reactant participating in a reaction. That is called stoichiometry. And calculations in stoichiometry are determined in mass amount. These are determined in mass amount, that is determined in gram. So at the stoichiometric reactions, we can see an example, that is how many oxygen is required for 10 gram magnesium to produce magnesium oxide. This type of mathematical problems will be found at stoichiometry. So the solution will be like this. We have to write down the reaction at first. We have to always write down the reaction at first, and then we have to balance the reaction. This is the main requirements to solve stoichiometric problems. First of all, we have to write the reaction by uh, understanding the question, and we have to also balance the reaction. If we do not balance the reaction, the mathematical problems will not be correct and it will be wrong. So here we are seeing that oxygen and magnesium are related in this question. So the mass of magnesium is determined and mass of oxygen is also determined. So oxygen is required here. So 48 gram magnesium reacts with 32 gram oxygen, and 10 gram reacts with this amount of oxygen. So this is the format of mathematical problems presented in this section. So here we can see another example, that is how many molecules of ammonia will be produced from two nitrogen molecules. So we have seen the example of gram amount, and now we will see an example of molecule amount. So how many molecules of ammonia this is required? Excuse me for a moment. So here we can see that an example of ammonia. So nitrogen and hydrogen are making ammonia and the reaction is balanced here. So uh, we all know that in a standard amount, the Avogadro number of molecules always participate in the reactions. So here Avogadro number of nitrogen and ammonia is participating in this reaction. This is the format. So required value is ammonia. So ammonia will be at the right side and nitrogen will be at the left side, and 4 molecules. This is the answer. By this format we can obtain the value. This is a mathematical problem. So next point will be limiting reactant. So limiting reactant I can make you understand with an example, that you are making burgers. So you are making burgers and you have 5 burger buns and breads, 5 burger breads and 4 patties. So you have 4 patty and you have 5 buns. So if you can make 4 burger completely, and then one patty will be short and one bun will be excess. So the bun is short in supply, so the bun will be the patty is short in supply, so the patty will be limiting reactant here and bun will be excess. So limiting reactant means the reactant or the substance which is short in amount. So we were making burgers and we have seen that the patty is short in supply, so the patty will be limiting reactant. So the limiting reactant means the substance that will be finished first while forming a product. So the amount of limiting reactant is calculated by stoichiometric method, that is in gram amount. So let's see a mathematical problem, that is 75 gram chlorine gas is mixed with 5 gram hydrogen gas. Which one will be the limiting reactant? This is the question. So the reaction is pretty simple. Hydrogen and chlorine are forming hydrochloric acid. So we have determined the value of hydrogen and chlorine participating here. So limiting reactant, the calculation should be focused within the reactants participating, not the products. Okay, so here only hydrogen and chlorine are participating, so we have to determine the amount of hydrogen and chlorine participating in this reaction, not the hydrochloric acid part. The product will not be necessary here. So we are determining that hydrogen and chlorine are participating, and for 5 gram hydrogen we need 177.5 gram chlorine. But let's look at the question here. The question says that 75 gram chlorine gas is in supply. So to completely react with 5 gram hydrogen, more amount of chlorine is required. Here we can see that this amount of chlorine is required for 5 gram hydrogen, but only 75 gram chlorine is present in our supply. So chlorine will be the limiting reactant. So this is a method that we can use, and we can use the opposite method, that is we can determine the value of hydrogen, that how many that 75 gram chlorines are reacting with how many amount of hydrogen. That 75 gram chlorine reacts with only 2.113 gram hydrogen, but the question says that there is 5 gram hydrogen gas is present, but 75 gram chlorine is reacting with only 2.113 gram. So excess hydrogen will be present in the reaction. So chlorine is ultimately the limiting reactant. You can determine the substance which is in excess, or you can determine the substance which is limited. So both, in both terms you will find the limiting reactant. It will be in short, or the substance that is in excess amount, the other substance will be the limiting reactant. This is the concept here. And the next last lesson of this chapter will be the percentage of yield. So the percentage of yield, it comes from the pure amount of product. That is, pure substance is called annular product, but in reality 100% pure substance cannot be obtained. Annular substance is kind of 99% pure. So the ratio of obtained product by the calculated amount of product in percentage amount is called percentage of yield. So percentage of yield will be the amount of product obtained divided by calculated amount of product into multiplied by 100%. So mathematical problem, here is a mathematical problem here. So 2 gram magnesium reacts with oxygen and forms 3.25 gram magnesium oxide. So you have to calculate the percentage of yield. Now the process will be the same, just you have to write the reaction and balance it. So now you are determining that magnesium forming with reacting with oxygen to form magnesium oxide, and we are gaining 3.33 gram magnesium oxide. By arithmetic method we obtained that, and calculated amount is 3.33 gram, but we have obtained 3.25 grams. So now we can all easily calculate the percentage of yield, that is 3.25 divided by the calculated amount. So the yield will be 97.598%. So this is the type of math that should be in your exercises or in your books. You can easily read the books and you will find many examples here. This is the determination method for percentage of yield. So we have seen a mathematical problem, and we have reached the end of our slide. So I hope that you will like this video, and you will practice more and more to make yourself better in this chemistry section. So I hope that you will take care of yourself and stay safe, and take necessary precautions while going outside. And if you have any problems, you can contact with me. So please, this is the end, and take care.